Before you begin watching this video, please make sure that you've finished the problems from Chapter 4, Section 3, PowerPoint, the rest of the proofs that we left off at. We're going to go over the strategies behind them and look at what the proof write-ups will say. So in this one here, we're given the fact that segment AD bisects segment BE. So I've got a pair of congruent segments that I can tick mark. Segment BE bisects segment AD as well. So I have another pair of congruent segments. I was given angles A and D congruent. They're already marked for me. And when I look at the diagram, I can see that I have a pair of vertical angles at C. So when I look at my diagram here, I can see that I have one missing set of tick marks at angles B and E. But since I already have two pairs of congruent angles between the two triangles, I can use my third angles theorem to be able to get those two angles to be congruent. And once I've established all of my congruent pieces, I can start writing my proof. So here's what it's going to look like. I've got my given angles, I've got my vertical angles, and I've got my third angles. They're my three pairs of congruent corresponding angles. I've got my given pair of sides, and I've got my couple of bisectors, which means that I have a couple of pairs of congruent segments because of the definition of a segment bisector. Now, once I have 1, 2, 3 pairs of congruent angles, in addition to 1, 2, 3 pairs of congruent segments stated in my proof, I can go ahead and say that my triangles are congruent using the definition of congruent triangles. For the next one, I was given two segments bisecting each other, so PR bisects QT, so QT is cut in half at S, and QT bisects PR, so segment PR is also cut in half at S, so I've got my tick marks there. Angles PQS and RTS, PQS and RTS are congruent angles, and segments QP and RT are congruent. That's all of my given information. That's all of my tick marks. I'm trying to prove that triangles QPS, so this small triangle on the left, and triangles TRS, the small triangle on the right, are congruent. When I look at those, I can see 4 pairs of tick marks, but I'm missing 2 pairs of ticks in the angles. So when I look at my diagram a little bit further, I'm going to see that I have a couple pairs of vertical angles at S. And once I have 2 pairs of congruent angles within each triangle, I can claim with my third angles theorem that my last pair of angles are congruent. So there are my 6 pieces of information that I need: 3 pairs of congruent sides, 3 pairs of congruent angles, and I'm ready to write my proof. So there's my 3 pieces of given. My segment bisector gives me 2 pairs of congruent segments in step 4. My vertical angles give me a pair of angles that are congruent, and once I have 2 pairs of congruent angles between the 2 triangles, I can use my third angles theorem to get my last pair of congruent angles. So I have 1, 2, 3 pairs of congruent angles, as well as 1, 2, 3 pairs of congruent segments. Once I have that all in place, I can claim that my triangles are congruent, again with the definition of congruent triangles. One of the things that I want to mention here, as I put in the last step, is that the order in which I put these segments, these statements, matters a little bit, but not totally. For example, the vertical angles theorem could have been put anywhere in this proof because they're not dependent on anything else happening. Vertical angles are congruent whenever I see them in the diagram. However, I can't use the third angles theorem until I already have 2 pairs of congruent angles in place. I can also only state that my segments are congruent from my segment bisector after I've stated that the two segments bisect each other. I don't have to have it directly after, but I need to state that given information before I can claim that the two pairs of congruent segments are congruent with my segment bisector definition. So I have some flexibility, but not total flexibility when I am writing these proofs. So the next one. This diagram might have been a little bit hard to read on your handout. Hopefully it wasn't too dark. But segment MK bisects segment JL. So I have another segment bisector here. Segment MK bisects segment JL. Segment JL bisects segment MK. So I have a segment bisector here as well. Segments JK and ML at the top and bottom of the diagram. Well, look at that. I have 3 pairs of congruent segments tick marked already. Segments JK and ML are parallel. Parallel. That's going to give me some alternate interior angles that are congruent to one another. So I can get angles KJL and JLM congruent because of PAI. I can do the same thing with angles JKM and LMK. And I also don't want to forget about my vertical angles here at N. So I have 3 pairs of congruent angles and 3 pairs of congruent segments. Now, I could have used third angles theorem if I had established 1 pair of congruent angles with PAI and then used my vertical angles as a second pair of congruent angles. So I could go that route as well. So here's a sample write-up. The givens giving me a pair of angles congruent by PAL. Another set of givens giving me my congruent segments with the segment bisector definition. This case here, I'm going to use my vertical angles and get angles KJN and MLN congruent by the third angles theorem. As I said earlier, I could have used another PAI to get those 2 pairs of angles congruent, those 2 angles congruent. But once again, once I have 3 pairs of congruent segments, and that's going to be the theme here, as well as 3 pairs of congruent angles, I'm ready to state that my triangles are congruent by the definition of congruent triangles. To finish off the rest of this, given the triangles are congruent, I can write an algebraic equation and solve for the value for x to be 31. And plugging that in gives me the length of AB being 74. Looking at the way the congruent statement is written for 2 and 3 tells me that segments NO and RS are going to be congruent to one another, as well as angles T and then P will be congruent to one another, because those are our corresponding pieces. And a final proof here, C is the midpoint of segment BD and of segment AE. So tick marking the midpoint of segment BD and the midpoint of segment AE. Taking my angles that are congruent and tick marking A and E. Taking the other pair of congruent segments that are given to me. That leaves me again 2 pairs of angles short in this diagram. I'm going to be able to use my vertical angles at C to add a second pair of congruent angles. And once I have that, my third angles theorem will allow me to get angles D and B to be congruent. So once I have all 3 pairs of segments and angles established as congruent, I can go ahead and write my proof. So here's your final piece here. The givens of a pair of angles and your midpoints. Pair of congruent segments in number 3 using the definition of a midpoint. My other pair of congruent segments. My vertical angles coming from the diagram. Angles B and D, as long as I have 2 pairs of angles congruent already, I can establish that those third angles, angles B and D, are congruent with my third angles theorem. And 6 pieces of information, 3 pairs of congruent segments, 3 pairs of congruent sides, gives me congruent triangles using the definition of congruent triangles. So, there's my proof using the definition of congruent triangles. We will later find other ways to prove that triangles are congruent, but for now all we have is the definition of congruent triangles to be able to work this through.